Okay, we're on air.
Yeah,
Hello.
hi Joel. Yes, hi
Yeah.
everybody.
Yeah, we're supposed to do was it 2 minutes of small talk?
Yes, I guess.
Oh.
What do you want me to ask?
Well,
That's-
are you ready for the presentation?
I am. I definitely am. I'm
Any
still
last minute changes?
no last minute changes. I'm well
No
prepared.
last minute.
Yes.
You don't want to open it and let me edit some stuff right now?
No, not now. Not a good time. Definitely.
Okay.
So we have this talk called Playful Testing Framework, right?
hmm
And you still don't like the name of the talk. So why again?
I didn't get the pun, and I don't. I guess I'm just embarrassed that I didn't get the pun.
Oh, okay. So for everybody, the pun is that playful means like playing with a kid, and playful
Mhm.
is also play is a scene, right, in a theater. So and playwright is kind of a theater thing,
Yeah.
whatever.
Yeah.
Yeah.
Don't worry, no one else will get it either.
Okay. Shall we start?
Sure. I don't know.
Yeah. Let me share my screen. Okay. Are we live? Awesome. Okay, so welcome to this talk, and here we will talk about Playwright Test. So, what is Playwright Test? Well, Playwright Test is a cross-browser web testing framework. It is written in Node.js, and this basically means that you can author your tests in JavaScript and or TypeScript. Now, Playwright Test is free, open source, and sponsored by Microsoft, and is already extensively used in the industry. But the big question is, why did we create yet another testing framework? And honestly, we did not want to. We tried them all. We tried Mocha, we tried Jest, but it turned out that none of them really worked for us. And I think that the reason is that historically, JavaScript test frameworks were built for unit testing, but end-to-end testing has this unique set of challenges. And we actually built Playwright Test to address these challenges. So what are these challenges? Things like, for example, out-of-the-box cross-browser support. You don't need to set up any plugins or do any mess with the configuration. It just works. Parallelization, for example. Well, we know how to run things and how to reuse things in browser efficiently, so we can run things really fast. And so do isolation. Like in unit tests, you usually do isolation on the Node.js side, and we have to isolate tests inside the browser. And there are way better ways to isolate things in browser. And last but not least, we actually want to have a crazy level of flexibility for our end-to-end tests. And we were really impressed by PyTest fixtures. And we didn't see anything like that in JavaScript world. So we implemented these ideas of fixtures in JavaScript and in the form of Playwright Test. Okay, so let's start with the talk. And we have a small agenda here. We'll cover a lot. So without further ado, let's get started. Okay, and the best way to show something is actually to show something. So right here, I'll hop to my terminal. Here it is. And I'll actually start from scratch, and I'll start using Playwright Test right away. So usually I do this, create a new folder, but this time around I'll do npm init playwright demo. So this is a fancy command, and what it does, it initializes a new folder for me. It's called demo, and it bootstraps it with an npm project, which is already configured with Playwright Test. And during this process, it will ask me a bunch of questions. For example, which language do I want to use for my tests? And sure, we are in the 21st century, so I pick TypeScript. And where do I put my tests? End-to-end. And do I want to have a GitHub Actions workflow? Sure, why not? So once I answer all the questions, it will do all the job, and it will present me with this bunch of bootstrapped files. Let's actually go inside this folder and explore what we have pre-created for us. So this is just a very simple Playwright test. So let's pretend I don't know what's Playwright, and maybe you don't know what's Playwright. Let's just read it. So we import something from this library. Easy. Well, we define a test. It is a basic test. And, well, it's already given some page. I don't know what this page is, but I know that I can navigate it. So it looks like a browser page for me. And then I can, I select some element. I locate some element on the page by text. And then I click it, crystal clear. And then I expect that this page has a certain title. Okay, so it looks like it's very readable, even though I don't know any of the Playwright test. It's already pretty good. Okay, what else do I have? I have this Playwright configuration file pre-created for me. So let's go and look at it. So it has a lot of information, but it's all heavily commented. So I actually will strip down these comments. We don't need them. We don't need these either. Important part here is this projects list. Projects are kind of like configurations. So we have only one test, and we want to run this test against different browsers. And we can specify these browsers or configurations in this list of projects. So for example, we will run this test in desktop Chrome and in desktop Firefox, Safari, and even in mobile versions of browsers like mobile Safari and mobile Chrome. So now if I go on and run these tests with this npx playwright test command, it will actually run 5 tests for me. So I have this example spec.ts basic test, and this test is being run under 5 different configurations: under Chrome, Firefox, Safari, and then mobile versions of both Chrome and Safari browsers. Now we also see that it actually happens in parallel. It runs 5 tests using 5 workers. And this is because Playwright test is parallel by default, and it has all these beautiful ways to configure multiple different setups. Now, we did not see any browser windows popping up onto the screen. And this is because everything runs headless by default. Now, I can actually run it headed, and we'll see what we will see in this translation. But we can see all these browser windows popping up, and they overlay each other because we are actually run in parallel. Now, if I don't want to run in parallel, I can, of course, say workers 1, and it will run these tests one by one. And you see these check marks are appearing one by one again. So it's much slower, so we will not wait for it to conclude. Okay, so it was just a few minutes, and it was really easy for us to start with Playwright because we did npm init playwright. And actually, I use this command to create a new folder and to bootstrap a new npm project. But I can use the same command to actually set up Playwright test in an existing project. So you just say npm init playwright, and it asks you all the same questions. And you end up with a Playwright test working and pre-set up for the project. Cool stuff. Now we learned how to also run tests with npm playwright test. And we took a look on this example test that was pre-created for us. And I want to actually stop here for a little, because in these just 7 lines of code, we have a lot of fundamental concepts that we have in Playwright. So for example, this page, it is given for us by Playwright test, but it is very well isolated from all the other tests. Then we were doing this click, and we didn't do any set timeout or anything. We just, this element, it might have been on screen, but we didn't care because Playwright test has auto waiting built in. And last but not least, we had this fancy expect that has a good idea of what page is, and that page might have a title. And this is called web first assertions. So these are 3 pillars, 3 fundamentals of Playwright test. So let's talk a little bit more about them. So first was test isolation. Now, in old school web testing and automation solutions, you usually have this trade-off. You either run your tests in a very reliable way, like For example, you want to restart the browser every time because you don't want the test state to clash with the test from the other test. So states have to be isolated. The best way to isolate states is to restart browsers. But this is slow, and it takes a lot of memory, and it's time overhead. Or on the other hand, if you want to run your tests fast, then you don't restart the browser, but have to resort to certain heuristics on how you manage and make sure your tests are reliable. Maybe you use iframes, maybe you use something else. None of these actually really work in practice. But in Playwright Test, you don't have to do this trade-off. We actually have test isolation based on browser contexts. And this is a technology that we built in all of our browsers. And this lets you isolate tests without any overhead. Like instantiation of new browser context is crazy fast. It's 1 millisecond. The memory overhead is negligible. So if you have 100 tests, they will just start very fast, and they all will be very well isolated between each other. Next up, auto-waiting. So old school web testing has this reputation of being flaky, especially if we talk about end-to-end cross-browser tests. And usually the reason is because I'm trying to click certain button, but this button is not on screen. Things like that. And usually the way to solve these issues is to throw in a bunch of wait for element or set timeout statements here and there. Now, these things don't really work that good because when we are in the cloud, there is no notion of time. So set timeouts are busted. And wait for element might work here and there, but it makes all the code very clumsy. Well, in Playwright Test, you don't need to do any of this. There is a built-in auto-waiting that just works. So every time you do any action or interaction with a page, all the elements are auto-weighted. So let me give you an example. So for example, we are doing a click on the page, like we did in our example spec. So every time we do a click, Playwright will make sure that the element is, well, first attached to the DOM, then that it is visible, then the element is stable, and this means that it's not shaken, there is no CSS or JavaScript animation running, and that it also receives events. And this is to make sure that there is no glass pane over the page that you might not see because it is transparent, but it captures all the pointer events. And last but not least, if we are trying to click a button, we want to make sure that the button is enabled. And this is auto-waiting, and this all happens automatically. Next, assertions. In old school web testing, we usually assert current state of the page. For example, I click a button and then I go in the page and say, hey, does this page has this element, or does the page have this text, for example? So this unfortunately doesn't work that well because modern web applications are highly dynamic and their state is always in flux. So instead of going and checking the current state of the page, in Playwright Test, we declare expected state. And we say, please wait until this page reaches this certain point of its lifetime when it has this certain title. So we call these web first assertions, and we have a whole lot of these in Playwright built in already. Now, you might see that all of these methods actually accept locator as an argument. So I have to share a few words about locators. So locator is this concept in Playwright. It's basically just a pair of a page and selector. It's very simple. So you can create locator with this page.locator call, and every time you do an action with a page, well, it will requery the page for this element. So it's really simple. It's strict by default, meaning that if you try to click a locator and the locator is not strict enough, and you have two elements that satisfy the selector, it will complain and say, well, please come up with a better selector for me. Okay, so now we know what locators are. Let's dissect this a simple web first assertion. So it's really simple. We go and make sure that certain list of products have exactly two products, which is a soap and a rope. Now, it has three parts today. First, all of the web first assertions have to be awaited because they are asynchronous in their nature. So then we pass in a locator, and this expect will requery given locator until we have exactly two of these items. And the first one will have a text of a soap, and the second one will have a text of a rope. So these are web first assertions, and this is a real quick recap of this chapter, fundamentals. We just saw how we do isolation in Playwright. We learned about auto-waiting, and we learned about web first assertions that ensure declared state. Good. Let's move on to configuration. And this is our chapter number 3. So for the configuration, I'll bring up our test, example.spec.ts. And here in this test, we already talked about this page that is given to us by the Playwright test. Now, how do I configure this page? Turns out that the first method to do this is to use configuration file, like we've seen already in the demo. And I have this projects list, and I can have this configuration with a desktop Chrome. And every time I run this test, the page will be a Chrome page. Now I can throw in a bunch more projects, and if I were to run this configuration now with npx playwright test, I will have 3 tests. So this example spec will be run against desktop Chrome, desktop Firefox, and desktop Safari. Okay, so this is good. This is kind of like a matrix of jobs that we have to do. But how do I do a more granular configuration of a page? So let's say, for example, I have an international website, and I am very worried about the experience of French users of my international website. So I want to create a test suite that makes sure that the experience of my French people are really, good. So let's do this. Let's open this france.spec.ts. And the very first thing I will do in my new spec file is put in this top level command, test.use. Now inside of this command is an argument. I can specify locale, which is French, and the time zone ID. Now all the tests down in this file will be run inside this project configuration, which is extended with this time zone ID and locale. Now I can go even further. I can create a test suite that makes sure that the light color scheme for my French users is actually reasonable. So I can create a new test suite with test.describe, and inside this test suite, I can say test.use once again and extend the configuration with a color scheme argument. Now all the tests inside this test suite are running in Paris and also in a light color scheme. And obviously I can do the same with a dark color scheme. Now, getting back to the reasons of why we actually originally created Playwright Test, this is a good example of flexibility. We don't know any other JavaScript testing framework that lets you so easily configure your tests. And this is what we call fixtures, and this is what actually coming from PyTest. Okay, so we had these words like locale, time zone ID, color scheme, and these are all configuration options. And turns out we have a whole lot of them in Playwright Test already built in. And if you want to read more about this, here's a short link, aka.ms/playwright/fixtures. But long story short, you can configure a network to be offline, you can configure geolocation, extra HTTP headers, and so on. Okay, next up, data-driven tests. So what is this? Let's say, for example, I have this urls.json file, and it has just a bunch of URLs, and I want to make sure that all of these URLs are actually loaded properly. So to do so, I can create a new spec file, which is checkurls.spec.ts, and let's code it. So here I have my checkurls.spec.ts. I have my usual header that imports test and expect from Playwright Test. But now I will actually get my URLs here in the context. Now I will just iterate over the URLs And for each URL, I will create a new test. Inside this test, I have the single page.goto statement that just navigates to this URL. And if the navigation succeeds, then the test passes. Otherwise, it will throw. Now, one important thing here, we have to make sure that all the tests have different names. So here, for example, I included URL as part of the test name. Otherwise, Playwright Test will actually complain. Okay, next up, reporters. So we know that reporters is very important for everybody, and you can easily configure reporter through a CLI flag. Like you can say dash reporter dot, and you get this dot report of your test runs. But actually, it's much easier and nicer to use configuration file. It is still the same configuration file we use throughout this presentation. So I will add a single line, which is a reporter equals dot, and this is how I can set up a reporter. Now, usually, however, I want to have one reporter for local experience, a more interactive one, and a more simple textual one for the CI. So we can implement this using this process.env.ci environment variable, and we can use either one or the other. Now, these are terminal reporters. I can also have JSON reporter or a bunch of reporters. If I have this array of different reporters, I can configure a JSON reporter side by side to my terminal reporter. In Playwright, we have a bunch of built-in reporters like dot, list, line, JSON, and even JUnit. And there is a third-party reporters as well. The most prominent one is Allure Playwright. If you want to learn more about reporters, please head over to our short link at akams/playwright/reporters. Okay, next up, devices. Now, let's get back to our configuration file. And let's do two things. First, we will just import devices. They come bundled in Playwright Test, so I don't need to do anything else. And now in each of these projects, instead of using this custom browser name, I will just use my device. So for Chrome and Firefox, these are very simple. I just do devices, desktop, Firefox. And for Safari, let's do something more interesting. For example, I'll substitute Safari for mobile Safari. And I will use iPhone 12 Pro as a configuration for the tests. So now if I run my tests against this configuration, I'll get this emulated Safari, iPhone Safari actually. And this is how easy it is to actually test against mobile devices. Okay, so far we talked all about very technical stuff, like configuration and programming, but I want to show you something more maybe enjoyable, more fun, because Playwright actually comes with tools. And in this chapter, I want to show you our beautiful Playwright inspector and code generation tools. So let me hop back to our terminal. And the first thing I'll do npx Playwright Test, but this time around I do -- debug and also -- project desktop Chrome. So as I launch this, two windows open on my screen. First is this Chrome window, and Chrome window will be used by Playwright Test to actually run tests. So let me resize it, and let's take a look on the other one. And I will actually zoom it in so that you can see it better. So this second window is a Playwright Inspector window, and it has quite a lot of things going on here. So let me actually show you around. So in the very middle of the screen, we have the source code of our example spec.ts. And we have this blue execution line paused on the very first statement. So I can actually advance this execution line, and it means that the page is actually paused, and I can go up there to the control panel and hit the step over button to move to the next statement. Now we can see the execution line is advanced, and my website actually loaded this Playwright page. And down here, in the end of the screen, I can see a log of all the actions that the test is doing. So for example, I can see that page go-to navigated successfully to my playwright.dev, and I have this green check mark, and I know even how long it took for it to navigate. And I can see that locator.click is currently paused, trying to click this get started text. Okay, remember we were talking about this auto-waiting functionality that is built in? So here we have a log of all these auto-waiting things that happened behind our back. So we resolved this selector to a certain element, and then we made sure that it is visible, enabled, and stable. Then we scrolled it into the view, and then we made sure that it receives pointer events at certain coordinates. And these coordinates is where we are actually aiming right now. And if we go back to the browser window, we can see this red dot. And this is where Playwright is about to click, and this is where we are aiming, and these are the coordinates that we validated. Okay, and last but not least is this middle section. So this is called Selector Playground, and it has two parts. It has this Explore button and this input field. So input field is actually where we can go and play with selectors. I can, write different CSS selectors or XPath selectors, actually Playwright selectors in here, and play with them. For example, I can say text equals API, and I can say ends equals 2, and this is called selector chaining in Playwright. So this is cool, but I want to show you this Explore button. It's actually my favorite. So when I click this Explore button, my Chrome window will pop up. So let me do this. Bam. Now, as I hover over the different elements on the page, I can see there is a small text on the black background under my cursor. For example, here is text equals get started. And this is the selector that will be that I can pick. So I can hover over this API, for example, and it says text equals API. Now I can click on this element, and this selector actually pasted into this input field, so I can further refine it. I can say CSS equals body, whatever. I can play with it. I can make it better. I can copy it and paste into my editor. And this is Selector Playground, and this was the Playwright Inspector. So I will just resume the execution so that it concludes. Okay, so this was pretty cool, but this is how we debug tests. Let me show you how we can actually author tests. And for this, first of all, I will use CodeGen tool, and I will save the results right away to github.spec.js. So let me launch this command. Okay, so once again, we have two windows popping up. Again, we have a Chrome window, and again, we have a Playwright Inspector window. This time around, Playwright Inspector has this record button highlighted with the red color. Let me change the layout a little. Okay, so this red recording actually means that every time I do something in my browser, like let me navigate to Microsoft, you can see that it records my actions. And now we have the navigation recorded. And now I can just go on and type things here, like Playwright. And I'll just do things in my browser. Now, interestingly, here again we have this overlay with a selector that will be used if I were to click this element. Like here, I can click both this number, which is text 352, or the issues label. Well, this selector is obviously not reliable, and I want my automation to be reliable, so I will click issues. And I will type electron here. Let's look for Joel. Here is Joel. Joel, you have a bug you have to fix. Okay. Good enough for a script. It has good 50 lines of code. Let me exit my Chrome and let's take a look. Does it actually record it? Okay, so this is our automation. Now, to run this automation, I can just use npx Playwright Test GitHub, and I want to run it only on desktop Chrome project. So here it is, it's running. Let's see how long it takes for it to conclude. Oh, 7 seconds. And we didn't see anything happening. Let me actually do it in a headed mode so that we can follow how it works. So it navigates to Microsoft, goes to Playwright, and yes, it's super fast. So this is how we actually author new tests. And if I want to, I can, go to my editor and edit these tests if I wish so. So these were inspector and CodeGen. Now, quick recap. We had this Playwright inspector, and we used --debug to debug our tests. We have this Playwright CodeGen command, and we use it to generate new tests if we want so. And in both ways, we are presented with this beautiful Playwright inspector UI that has control panel, source code, actions, and my personal favorite, Selector's Playground. Okay, so this was cool. Now, during this demo, we used Playwright Inspector to debug the local failure. Now, what would we do if we have a failure somewhere in the cloud? For example, I have a test that fails on CI, and I cannot reproduce this failure locally. Well, of course, we can record a screencast or take a screenshots, and Playwright Test has all of these capabilities bundled, built in, so you can do this. But wouldn't it be cool if I can actually deep dive into the test run? I want to go and see what was in the browser console during the test run. I want to go and see what was the network traffic. And finally, I want to go and see and look inside the DOM of the actual browser during the test run. So it turns out all of this is possible. So let me introduce you to the Playwright Tracing, and actually to the Post-Mortem debugging with Playwright Tracing. So first of all, a little bit of a terminology. So what is Post-Mortem debugging? So we call debugging the test failures on CI. If we have something that's failing that we cannot reproduce locally, then we have to do a post-mortem debugging. And we usually rely on test artifacts to do so. And test artifacts are actually any byproducts of test running, such as logs, screenshots, or videos. Now, in Playwright Test, we have this unique type of artifact. It's called tracing. And it turned out that tracing is just so much more superior than both videos and screenshots combined. So let's see what it is. So Playwright Tracing is a technology that consists of two parts. First, it's a trace.zip files, and this is a portable file format that stores all the information about the test run. Things like Playwright actions, Playwright events, screencast, network log, console log, and even DOM snapshots. For each of the actions, you have a deep dive into the DOM of the page. And next, we have this trace viewer, which is a graphical user interface tool that lets you explore these trace files. And you don't need to do anything. All of this is already bundled in the Playwright Test. But there are a few things you have to do before start using it. First, you have to enable tracing in your Playwright configuration file. Next, you have to set up your CI or a cloud environment to upload these trace files to some artifactory or repository where you can download them from. And last but not least, you don't have to, but you need to download and inspect these traces with the Playwright Trace Viewer. So let's go over the steps one by one. So first, Playwright configuration file. Now, first thing, if you do npm init playwright, then Playwright configuration is already pre-set up for you to record traces. So you don't need to do anything. Second, we can enable tracing for all of our test runs. And it doesn't have that much overhead, but it still has some overhead. So if we want to have no overhead whatsoever, we need to enable some retries and then record the trace only on the first test retry. And this is the optimal way for us to do a trace collection, and this is what we actually recommend doing. Okay, first bullet check. Next, configuring continuous integration. Now, there are numerous different continuous integration services, and we cannot go over all of them, but we personally use GitHub Actions a lot, and it's really simple to upload artifacts on GitHub Actions. We just need to add this new upload artifact action in the very end of your job, and you use test results as the path for the artifacts to upload. And the test results is this folder that stores all the artifacts that Playwright collects. And if you set up Playwright to collect screenshots or videos, they all go to test results as well. So last but not least, we want to download the trace and go and look around in Trace Viewer. So let's actually do this. So I have this GitHub repository, which has an actions setup. And inside these actions, I have a failure. I was running my Playwright tests and something didn't work. It says timeout, exceeded. And it even tells me where. Now, right here in the output, I have this command. I will copy it. But before I can use this command, I need to download this trace file. So this one is copied. I'll go to summary of this build run. And down here, I have this test results, right? Now, I already downloaded this for the sake of this demo. So I have this test results folder. So I'll go to my terminal and I'll actually paste this command. Downloads. Oops, it's the wrong place. Here. Downloads. This opens up this trace viewer UI. So it is pretty packed with information. So let me show you around. I'll zoom in, try to make sure it's big enough. Okay, so this UI has 4 parts. At the very top here, we have a timeline with a screencast with overlaid actions. So I can move over this timeline and see what was actually going on inside my test. So for example, here I can see that I was typing electron here. I also have these bars, and bars of different color mean different actions. Blue one is a navigation, and I see that it took Playwright 1.2 seconds, even a little bit more, to navigate to this GitHub page. Then I was clicking somewhere, clicking one more time, and filling stuff. So this is timeline, and here on the left-hand side, I have a list of actions. And these are all the actions that Playwright did in a chronological order. So these actions are keyboard navigable, and I can go up and down for them. And for every action, I can select it and see the things on the right-hand side. So for example, for this go to action, on the right-hand side, I can see all the arguments. I have a parameters. I can see this is a go to. I was navigating to this URL. I can see what was happening in the browser console during this call. And I see all the networks that was flowing through the browser during this navigation. So for example, I can see these parameters and, well, the website was loading an image. Okay, so for each of these actions, in the very center of the screen, we have DOM snapshots. And we have a few of them. We have a snapshot before the action. And here we were navigating from an empty page, so before is empty, to the github.com. So the after DOM snapshot actually shows me the actual page. Now we also have this action snapshot. And this is a snapshot. Let me try to zoom it in. Okay. And this is a snapshot that's happening right before the action was happening. So here for the click, for example, I can see even a red dot. And this is where Playwright will click as it actually concludes the action. And this is pretty cool. And for example, for fill, I can see before and after. Before was empty and after has some text. And actually, yeah, did I say that these are actual DOM snapshots? So I can scroll this page. All CSS animations actually work. And here's an input field I can even type here, because this is DOM. And I can even go and open DevTools and use DevTools to inspect the DOM of the browser during this action, this fill action. So this is a real DOM, and I can inspect it. Now, we came here because something didn't work on CI, and right here we have this page click text equals woof action. So this seems to be some error because someone was trying to click an element with a woof text. Clearly on GitHub page there is no such text. So no wonder this action was interrupted, because Playwright was trying to wait for this element to appear, but it never did so. And this was trace viewer. So let's go back to our presentation. So what we learned? We learned that we can open traces with npx playwright show trace command. And once we do so, we are presented with this beautiful UI of 4 parts. We have a timeline where we can go and follow the test execution. We have actions list that has all the actions Playwright did in chronological order. We have action details where we can get all the details about the browser state during this action. And we have DOM snapshots for each action, and we have even 3 of them, which is a DOM snapshot of an action, of a before action, and after the action. Okay, so quick recap for today's presentation. What did we learn? We learned that we can start easily with npm init playwright, and we can both start new projects and convert existing projects to use Playwright Test. We learned that we can configure everything at playwright.config.ts, and there is no hassle. It's super easy to set up tests for iPhone and customize reporters or generate tests if you have some blobs of JSON data. And we took a look on Playwright tooling. We inspected things or debugged tests with the Playwright Inspector, and we created new tests with the Playwright code generation. And last but not least, we did a post-mortem debugging with the Playwright Tracing. So if you liked what you saw, please head over to our documentation, playwright.dev, to learn more. We are also present on social channels. If you like what we do, please subscribe to our YouTube, follow us on Twitter, and give us a star on GitHub. So my name is Andrey, and this was a talk about Playwright Test. If you have any questions, this is a good time, because I think we can go to discussion zone right now. Joel?
I was muted. Great talk. We've got some questions in the chat that I've been answering, but do you want to do 1 or 2 now, and then we'll go to Zoom?
Yes. Can I stop share?
Yeah,
awesome. I was given a permission.
So some people are asking, so do you want the easy question or a hard question?
You pick.
So easy question. They want to use Java.
So in Java, you have Playwright automation library, and you pair this automation library with JUnit. I think we officially support JUnit now, and we recommend everybody to use JUnit. So a year ago, we were given a talk here at the Heisenbug about Playwright, and we talked that Playwright as a library, as an automation library, exists in all the languages like Python, Java, and .NET. So you pick library for your language, you pair it with a testing framework for your language, and you roll. As easy as this.
Mm-hmm. And then hard question. Someone wants to know, how do we compare to Cyprus?
Good. So long answer. Cyprus is great in terms of developer experience, and we love its developer experience, and we want to get its developer experience to Playwright. However, in Playwright, fundamentally we have a different architecture. We are out of process, and this lets us have multiple languages, and this lets us create, these powerful automations, and we can be cross-browser easily. So we want to have both of two worlds, basically. We want to have out-of-process architecture that works across languages and across browsers, and we want to have a developer experience like in Cyprus. So best of two worlds is Playwright Test.
I think we're also, I say you could argue that we're better in the developer experience as well.
Sure.
Right. We're trying to be better.
We're trying to be better. Yeah.
Yeah. I think Playwright Test is a big step up for Playwright in terms of developer experience.
Yeah. Definitely. And all the tooling is nice. And actually, it's so much nicer to configure tests. And there is a real JavaScript, Well, I can say many things how I like personally Playwright and Playwright Test more than everything else. Yeah.
Okay, so let's go to the Zoom, I guess.
Yeah, I think I should close this tab. Okay, folks. Bye-bye, everybody. Have a good day. And whoever wants to join discussion Zoom, please meet us in Zoom.